Hello students, this video is designed to help with the Unit 1 Lesson 1, which is undefined terms. In this video I'm going to be talking about a couple of the different terms that you're going to need in order to define other different structures in geometry. It's kind of like learning some basic vocabulary words. Once you know these vocabulary words, you'll be able to define other figures in geometry, and we'll be able to use the same language together, which is always a useful thing. In our learning target here, it asks us, or it tells us, that we're going to be able to identify and name basic geometric figures, which means if you see a geometric figure, you'll be able to put a name to it. And also to draw specified figures. If I ask you to draw a specific figure, you'll be able to do that. And last but not least, we'll be able to compare and contrast their properties. Many of these figures are going to be similar, but they're also going to have different properties, which we'll get into right now. The first and most basic figure that we're going to be talking about in geometry is a zero-dimensional figure. That might sound like it's something from a sci-fi novel or something like that, but a zero-dimensional figure is really just a point. A point is sometimes described as a place in space, or also a location on a plane, or also described by coordinates. There's no formal definition for a point in geometry because it is one of the three so-called undefined terms. When mathematicians were planning out geometry, they said to themselves, well, I can't really give you a definition for point. I can describe it, but I can't define it. Same thing with the other figures that I'm going to be talking about during this video. But once we have the descriptions of these three figures, we'll be able to use those descriptions to build our definitions of larger figures and other things that are going on in geometry. So for now, we're considering a point to just be a place in space. The reason we call it a zero-dimensional figure is because it has no measurements. When you think about a point, you don't think about how wide the point is, how tall the point is, how deep the point is. You're just talking about a place. You're not measuring anything about it, you're just saying, well, it's there. When we talk about one-dimensional figures, however, we can start thinking about how they're measured only in one direction. If you think about any of these structures that you can see here, any of these figures, I'm not considering how wide they are, because a line is of infinitely small width. But I can measure how long it is, most times. Now, each of these figures that you see, each of these three figures, are pretty similar, but they have some very important differences. For example, this structure, you can see it starts at point A and ends at point B, or you consider it as starting at point B and ending at point A. It doesn't keep on going in either direction. We call this a finite segment. It is finite because it doesn't keep on going. However, this structure here, this figure here, starts at point A, continues through point B, and this arrow indicates that it goes on forever in this direction. You learned about this in Algebra 1 when you graphed lines and linear equations. And in this structure here, it does extend in both directions infinitely. So there are some similarities between these figures and some differences. Those similarities and differences lead to their different names. This first structure, or this first figure, I should say, is called a line segment. Sometimes people just refer to it as a segment. The second one is called a ray. A ray starts at one point and continues through another point, and a line extends infinitely in both directions. So the main difference between line, segment, ray, and line is in how many directions it extends infinitely. This extends infinitely in 0 directions, this extends infinitely in 1 direction, and this extends infinitely in 2 directions. You can also name these in different ways, and I'm going to show you those ways now. The notation is very similar, but slightly different. When I talk about line segment from A to B or from B to A, I can name it in either way. I can name it line segment AB or line segment BA. And notice I've put a straight line on top of it that doesn't have any arrows on it. This is the way that we name line segments, and it doesn't really matter which letter we start with and which letter we end with. However, on standardized tests like the Regents exam, it'll generally be in alphabetical order, so line segment AB is probably the way that you're going to see it most often. We already referred to this figure as a ray, and we're calling this ray AB. The reason it's important that we can't name it ray BA is because this ray has its finite point, its finite end point we call it, at A, and it continues on through B. So naming it ray AB indicates A is its starting point and B is the point that it travels through. And last but not least, when we're naming a line, we can name the line either line EF or line FE, depending on what 2 points lie on this line. Notice we can name them in any direction that we'd like, because just like a line segment, that line, we consider it sort of directionless. It doesn't matter whether we read it from right to left or left to right. However, as previously stated with line segment, we're generally going to be seeing it in alphabetical order. So if I'm giving you this question that's a region style question, you would see line EF. And notice that the line notation has arrows on both sides, the ray notation has arrows on only one side, and the line segment notation does not have arrows on either side. We just talked about one-dimensional figures, in other words, figures that are only being able to be measured in one dimension or one way. A two-dimensional figure is going to be more familiar to you. It's a figure that can be measured in two different ways. It has a width, for example, and a length, or a length and a width. Two different things that we can measure it on. This two-dimensional figure here is called an angle. It's referred to as two different rays, and you can see that this is ray BA and this is ray BC, connected at a common endpoint. That point is point B. Anytime we see two rays that are connected at a common endpoint, or less commonly, two line segments connected at a common endpoint, we refer to it as an angle. The next two-dimensional figure here is called a plane. When you think about a plane, you should think about the XY coordinate grid, because the XY coordinate grid has a horizontal axis and a vertical axis. That's 2 dimensions. So this is called a plane. Naming an angle is one of the skills that you'll need to have in a geometry class. So here's the name for this angle. Now this angle can be known as either angle ABC or CBA. I want you to see one commonality between these names. The one commonality that you see between these names is that B, which is the common endpoint, is in the middle of the name, CBA or ABC. That point is known as the vertex. As long as you name an angle with that middle letter, that middle point being the vertex of the angle, you've done it correctly. Doesn't matter in which direction you travel from one side of the angle to the other. That last figure here, the two-dimensional figure called a plane, I can name it based on any 3 points that are on the plane. So I'm going to give you a couple of examples here. Let's say for argument's sake there are 4 points that we've defined on this plane, Q, M, H, and S. There are a lot of different ways that we can name this plane now. You can essentially just choose any 3 letters that you'd like on the plane and define it like that. So I could refer to this plane as plane QMH, because Q, M, and H all exist on the plane. I can also call it plane SMH or plane QSM. There are a lot of different names that I can use. Most of the time when you're talking about a plane, you just pick 3 letters and refer to it as that. It's not necessary to name it with more than 3 letters. Moving on, I'd like to take a look at some descriptions of figures. Anytime you talk about figures in geometry, you'll either get a drawn figure, a diagram, or you'll get a description, and you'll be required to either draw the diagram or name the figure. So take a few minutes, pause the video, and try to identify what the name is of this diagram and what the diagrams would look like for both of these situations. Pause the video, and then come back to see when you're done whether you got it right. All right, here are the answers for those first 3. Line segment XV, again, as I said previously, it doesn't really matter in which orientation we draw this. You could have drawn it straight up or horizontally, as long as one of the end points says X and one of the end points says V. With this figure, we started at point B and point B and went through point A, so I'm calling it ray BA. It is not appropriate to call it ray AB because it does not start at A, it starts at B. And then for ray QS, I decided to draw it straight up and down. You could have drawn it horizontally or whichever angle you would like to have drawn it at. However, I'm starting at point Q and going through point S. Moving on to those next examples, pause the video, try to figure out the descriptions or the diagram, and then see if you got them right. All right, for that first diagram that was given, you had 2 options. You could either name it angle WTV or angle VTW, as long as that central point in this angle is named as point T, is in the middle, right? Make sure that the vertex is in the middle of that naming. If you were careful that you saw that there was an arrow on this side and there's no arrow on this side, that is okay. An angle is not necessarily defined by the fact that it has a ray. It could have a ray or it could have a line segment as one of its legs. In this example, we drew line AB, which is a line and has arrows at the ends of it, and it passes through points A and B, and CD, which is line CD, intersecting at point E. That point of intersection is point E. We couldn't have drawn 2 parallel lines because then they wouldn't have intersected. And last but not least, this could have been named several different ways, but we're I only wrote down two, plane QUI and plane IQU. Notice that I was only able to use these 3 points as the name because point Z is not clearly on the plane. It's off to the side here. And last but not least, regarding this name, I underlined this name because it is the most standard name you could refer to it as. And if you were observant, you knew that it was because this I, Q, and U are in alphabetical order. Let's move on to those last examples. Try to either draw the diagrams or write a definition or a description, I should say, in the boxes. One thing you may have noticed as you were going through these problems is that you had several different choices, several different options for how to draw the diagrams. For example, I drew angle DFG. I drew it so that it was opening to the right, like it has this open space, this interior of the angle to the right-hand side. I could have easily have drawn it this way so that the opening was to the left. It didn't really change whether it was called angle DFG. One thing, however, that was necessary for this diagram was that F had to be the vertex. F had to be the center of that angle. In this case, I identified this was line segment CD and line segment AB that intersected E, slightly different than the previous example because this is talking about lines AB and CD, and this is talking about line segments. And last but not least, it talks about collinear points. This word collinear, when you think of the prefix co, you think together. So collinear just means together on the same. So the way I drew it was I have A, B, and C as all 3 points being on the same line. You could have drawn the line any way you wanted. However, A, B, and C had to be present on that line somewhere. Take a few minutes to look at this diagram, which is a little bit more complicated. There's a lot more things going on, and try to name all the geometric figures. Specifically, we're looking for 0-dimensional figures, 1-dimensional figures, and 2-dimensional figures. Try it out. All right, the first thing that I named in this geometric diagram were the points, A, B, C, and D. These are all of my 0-dimensional figures. The next thing that I named are the lines. As a matter of fact, there was only one line in this whole diagram. It was the line from here to here that's named in 3 different ways. You could name it based on any 2 points that it passes through. So line AB, line AD, or line BD, they're all the same exact line, but you can name it in 3 different ways. It has 3 different names for the same thing. And of course, since they're lines, we notate it with the line with 2 arrows on either side on the top. Next is line segments. We can see that there are many line segments here, and those are indicated by starting at one point and ending at another point. We can name a number of them, for example, line segment AC, which is here. I can also name a line segment which is BC, from here to here. That's another line segment. A third one would be AB, from here to here. Now, I can use parts and larger sections of line segments within each other. For example, I have line segment BD here, which is another piece of this longer line segment, which I'm going to name AD. So there are a lot of different line segments that I can define in this one diagram. And of course, since these are line segments, we're going to notate that with a line above them not having arrows. All right, the next structure that I identified were rays. If I take a look at the rays, there are a number of different rays that are in this example. For example, starting from B and going through C, that's one unique ray. You know that AD starts at point A and goes through points D. DA is starting from the other side, starting from point D and going through A. So these rays are very similar because they cover some of the same ground, but they're not exactly the same because one of them starts at A and goes through D, whereas one of them starts at D and goes through A. A little distinction there. Ray BD starts at B and goes through D, so it's going in this sort of way here. And then ray BA is going to start at B and continue through A, which looks like this. And of course, since they're rays, we're using the correct notation for rays, which is no arrow on one side, but an arrow on the other side. And after that, I identified all the angles that I could see, ACB, ABC, CAB, and CBD. As a quick note, one of those angles, which is angle CBD, that's out here, this angle here. Make sure that when you're looking at a diagram, you identify all the angles, not just the angles that are inside a shape, a two-dimensional shape, but also the ones outside. All right, hopefully this was a helpful lesson. We talked about undefined terms, including point, line, and plane. We also talked about rays, line segments, and angles. Good luck studying.